9 over 4, or I just multiply them together. So 1 over 12 plus my 9 over 4 times 2 is equal to 14 over 3 TA cube plus by 4 TA cube. So I dropped the AT cube, right? So 4 TA cube, and then plus by 2 over 3 TA cube. So the second moment of area plus by 4 plus by 2 over 3 is equal to 28 over 3 TA cube. Okay, as I said, this is equal to 0. It's very small and insignificant. So that is why you can drop. So we found our I already. Okay, so we know our I. So we if we go back, so we have determined our I already. Okay, so by knowing our I, we don't know our V. V is a constant, right? So rule number 1, right? Rule number 1. Remember our rule, V and I are constant. All right. So we know our I. So V we don't know, but later on you realize the V can be cancelled. Okay, so it's okay. So next, we're going to find the shear. We're going to find the shear stress. Okay, am I going to find the shear stress? Hold on. Yeah, we're going to find the shear stress. Okay, I see. Do I have space? Oh, okay. We have. So next, we're going to find. So we know our I. We're going to find the shear stress in each section. Okay, we're going to find our shear stress in each section. Okay, so I'm going to copy this again so you can see. So this is where we construct our shear flow. Okay, so you guys have done this before. Okay, especially last week. Okay, so we know the web controls the shear flow direction. Okay, so these are all your Q, right? And then when that's the case, the shear flow has to go this way, and then you do this. Okay, then I'm going to call this F1. Okay, so this is how the shear flow moves. So now you're going to draw over it. Okay, so this entire one is known as your F1, right? And then this is your F2, right? Now coming down here along where touch go through your point C over here, right? Which is you will take your moment later on. This is your V, right? And then this is your F3. And then coming down here, that is your F4. Okay. So we have to find. Okay, so now we have to find. Okay, we're gonna find F1, F2, F3, and F4. And note, we know that F1 is equal to F4 and F2 is equal to F3. We know that. Okay. Right. So let's find F1. Okay, let's find F1. The map is really easy for this. Okay. F1. Okay. Acting on section AB. Right. AB. So I'm going to sketch. Okay. So if this is our centroid, hey, wrong color, sorry. If this is our centroid, right, and then over here, let me change the color. I do apologize. Over here, right? So this is your point A and point B, right? And then we have, so the distance from here to here is A, right? And then we are going to have our Y variable here. If your Y variable is there, this is the area of concern. This is the area of interest, okay? And we know that the distance from here to here is equal to T, right? So the Q for AB is equal to A or width multiply depth multiply Y bar, right? So we know the width is the thickness T, the depth is equal to 2A minus Y, right? Why 2A minus Y? Because the distance from here to here is 2A, right? Minus Y. Then over here, the Y bar is 2A plus Y times by half. We have derived this before. Y is it 2A plus half, okay? So this will be equal to T over 2, right? And then you have be 4A squared minus by Y squared, right? Then directly we put into the shear of AB, right, section AB, okay, as a function of Y, right? So this will be equal to V over IT, right? So you just need to include T over 2. Oh, sorry. I have to bring in the big bracket. T square bracket, right? So 4A squared minus by Y squared, all right? So this you can cancel the T, so it's V over I, 4A squared minus by Y squared, right? So this is our equation number 1. So from here, you can find force of 1. So force of 1 along section AB is equal to shear AB as a function of Y, or shear in section AB multiplied by dA, right? So the limits, right? So the limits in terms of Y is A and 2A, right? Because the distance here is A, this is 2A. So that is the limit shear AB as a function of Y. Now the area, so we know that it's multiplied by T, which is the thickness, and then by the variable dy. Okay, by dy, because dy is always changing. So this is your dy, right? So let me draw a transformation. I forgot the transformation. So this is y and z. Okay. So from here we just it's just matter of substitution. Sorry, I miss out a 2 down here. Okay. So this is equal to v over 2I, right? You integrate between a and 2a, 4a squared minus by y squared t, right? And then dy. In fact, T, you can bring it out. Okay, so I'm going to copy this again. I'm going to write on the next page. Give me 3 more minutes, then we go for our first break. As I said, the math is really, really easy here, okay? It's just a concept, right? So this will be equal to VT over 2I, right? So this is 4A squared Y minus by Y cubed over 3, and then this is 2A, okay? So again, method of substitution now. So this is VT divided by 2I. So you have 8A cubed minus by 8A cubed over 3, right? And then minus by 4A cubed minus by A cubed over 3. Okay. So when you do this, you get, so 8 minus 8 over 3 minus 4 plus by 1 over 3. So it's equal to 5 over 3. Okay, so VT over 2I, right? So this is equal to 5A cubed over 3. Okay, so you bring all of them together. So I, we know what is our I value, right? So we found our I value. So we go back. Our I value is 28 over 3 TA cubed. Okay, so 28. So VT over 2, 28 over 3 TA cubed. Right, and then this multiplied by 5A cubed over 3, right? So you can cancel the T, you can cancel the A cubed, right? So you are left with 5 times, so it's so 3 and 3 you can cancel, right? So 5 over 56, right? So 2 times 28 is 56 V. So this is equal to your F1, and F1 is also equal to your F4. Okay, I'm going to stop here. Okay, we take a 15 minutes break, then we find the next section. Okay, and then we solve the problem. Okay, I'm going to take a, let's go for a 15 minutes break now. We come back at 8:45. Okay.